Strong Cat5 cables and similar cables can be run through bar joists of a building without support straps if, and only if, the cables are secured to the bar joists in a way that ensures they will not move or fall out of place. This may involve using straps, staples, hangers, or other approved fittings. The cables cannot be run at any angle and not follow normal building lines. The cables must be installed in a neat and workmanlike manner. This means that they should be run in a straight line, parallel to the building lines, and secured at regular intervals. Running cables through bar joists without proper support is a violation of Article 300.11 of the National Electrical Code, which requires that cable assemblies shall be secured in place. It is also a violation of Article 725.6 of the NEC, which requires cables to be installed in a neat and workmanlike manner. Inspectors may not always catch these violations, but it is important to be aware of the code requirements and to follow them in order to ensure the safety and reliability of the electrical system. Article 300.11 addresses securing and supporting wiring methods. This section mandates that wiring methods must be securely supported. The intent is to prevent the wiring from becoming a hazard or nuisance. For example, unsupported cables can sag, creating a tripping hazard or obstructing access to equipment. The specific requirements for securing and supporting wiring methods vary depending on the type of wiring and the application. However, in general, wiring must be supported at intervals sufficient to prevent sagging or displacement. Supports must be appropriate for the type of wiring and the environment in which it is installed. For example, cable ties may be used to support non-metallic cables, while metal straps may be required for metallic cables in corrosive environments. Furthermore, wiring must be secured to structural elements of the building. This helps to prevent the wiring from being damaged by movement of the building or by other activities. For example, cables may be attached to joists, rafters, or walls using appropriate fasteners. In addition to the general requirements for securing and supporting wiring methods, Article 300.11 also includes specific requirements for certain types of wiring. For example, cables installed in suspended ceilings must be supported independently of the ceiling support wires. This prevents the weight of the cables from causing the ceiling to sag or collapse. Also, cables installed in vertical runs must be supported at more frequent intervals than cables installed in horizontal runs. This is because vertical runs are more susceptible to sagging due to gravity. Adhering to Article 300.11 is essential for ensuring the safety and reliability of electrical systems. By properly securing and supporting wiring methods, electrical hazards can be minimized, and the lifespan of the wiring system can be extended. Article 725.6 of the National Electrical Code addresses the installation of Class 1, Class 2, and Class 3 circuits. These circuits are commonly used for control, signaling, and power-limited applications. Article 725.6 emphasizes the importance of neat and workmanlike installations, ensuring that these circuits are installed in a manner that promotes safety and reliability. The requirements outlined in this article cover various aspects of cable installation, including support, protection, and separation. One of the key requirements of Article 725.6 is that cables must be supported by the building structure in such a manner that prevents damage from normal construction and usage. This means that cables should be securely fastened to structural components using appropriate straps, staples, hangers, or other fittings designed for this purpose. The spacing between supports should be sufficient to prevent excessive sagging or strain on the cables. Cables should be installed in a neat and organized manner, avoiding unnecessary bends or twists that could compromise their integrity. Article 725.6 also addresses the need to protect cables from physical damage. Cables that are exposed to physical damage should be protected by conduit, raceway, or other suitable means. This is particularly important in areas where cables are subject to impact, abrasion, or other potential hazards. The type of protection required will depend on the specific application and the severity of the potential damage. In addition to support and protection, Article 725.6 also addresses the separation of Class 1, Class 2, and Class 3 circuits from other wiring systems. These circuits should be separated from power conductors and other circuits that could induce noise or interference. This separation can be achieved by running the cables in separate raceways or by maintaining a sufficient distance between them. The specific separation requirements will depend on the voltage and current levels of the circuits involved. Following the requirements of Article 725.6 is essential for ensuring the safe and reliable operation of Class 1, Class 2, and Class 3 circuits. By installing cables in a neat and workmanlike manner, providing adequate support and protection, and maintaining proper separation, electrical hazards can be minimized and the performance of these circuits can be optimized. Furthermore, compliance with Article 725.6 helps to ensure that electrical installations meet the standards set by the National Electrical Code. This is important for both safety and regulatory reasons. Electrical inspectors will typically check for compliance with Article 725.6 during inspections, and failure to comply can result in fines or other penalties. It is therefore essential for electricians and other electrical professionals to be familiar with the requirements of this article and to follow them carefully during installations. In addition to the specific requirements outlined in Article 725.6, there are also some general principles that should be followed when installing Class 1, Class 2, and Class 3 circuits. These principles include using high-quality cables and connectors, ensuring that all connections are properly made, and testing the circuits after installation to verify their functionality. By following these principles, electrical professionals can ensure that these circuits are installed correctly and that they will provide reliable performance for years to come. The National Electrical Code is a comprehensive set of standards that govern the safe installation of electrical wiring and equipment. It is updated every 3 years to reflect the latest advances in technology and safety practices. Compliance with the NEC is essential for ensuring the safety of people and property. Failure to comply can result in electrical hazards such as fires, shocks, and explosions. The NEC is divided into chapters, articles, and sections. Each section covers a specific topic related to electrical installations. For example, Chapter 3 covers wiring methods and materials, while Chapter 4 covers equipment for general use. The NEC also includes tables and examples to help clarify the requirements. It is important to note that the NEC is not a design manual. It does not tell you how to design an electrical system. Instead, it sets minimum safety standards that must be met. It is up to the designer to determine the specific requirements for each installation. The NEC is enforced by local authorities, such as building inspectors. These inspectors review electrical plans and inspect electrical installations to ensure that they comply with the code. If an installation does not comply with the code, the inspector may issue a notice of violation. The violation must be corrected before the installation can be approved. The NEC is a complex document, but it is essential for anyone who works with the electricity. By understanding the requirements of the NEC, electrical professionals can ensure that their installations are safe and compliant. The NEC is based on sound engineering principles and extensive research. It is developed by a committee of experts from various fields, including electrical engineering, fire protection, and safety. The NEC is constantly evolving to keep pace with the latest advances in technology. The NEC is a valuable resource for electrical professionals. It provides the information needed to design and install safe and compliant electrical systems. The NEC is also used by insurance companies, building owners, and other stakeholders to assess the safety of electrical installations. The NEC is available in print and electronic formats. It can be purchased from various sources, such as the National Fire Protection Association, which publishes the NEC. The NEC is also available online through subscription services. The NEC is an essential tool for anyone who works with electricity. By understanding the requirements of the NEC, electrical professionals can ensure that their installations are safe, compliant, and reliable. Understanding the difference between shall, should, and may in the NEC is critical for proper interpretation and application of the code. These terms define the level of obligation imposed by a particular requirement. Shall indicates a mandatory requirement. When the NEC uses the word shall, it means that the provision is absolutely required and must be followed to comply with the code. Failure to comply with a shall requirement is a direct violation of the NEC. For example, a section might state that all receptacles in bathrooms shall be ground fault circuit interrupter protected. This means that ground fault circuit interrupter protection is mandatory for all bathroom receptacles. Should indicates a recommendation or advisory. When the NEC uses the word should, it means that the provision is not mandatory but is highly recommended. Compliance with the should requirement is considered good practice and is likely to improve the safety and reliability of the electrical installation. However, alternative methods may be acceptable if they provide an equivalent level of safety. For example, a section might state that conductors should be derated if they are installed in an ambient temperature above 86 degrees Fahrenheit. This means that derating is recommended, but it is not strictly required if other measures are taken to ensure that the conductors do not overheat. May indicates a permissive or optional provision. When the NEC uses the word may, it means that the provision is allowed but is not required. The use of a may provision is at the discretion of the installer or designer. For example, a section might state that flexible metal conduit may be used for branch circuit wiring. This means that flexible metal conduit is an acceptable wiring method, but it is not the only acceptable method. Other wiring methods, such as rigid metal conduit or electrical metallic tubing, may also be used. In addition to shall, should, and may, the NEC also uses other terms to indicate the level of obligation. For example, the word require is often used as a synonym for shall. The word permitted is often used as a synonym for may. It is important to pay close attention to the wording of each section of the NEC to determine the level of obligation imposed by the requirement. Failure to understand the difference between shall, should, and may can lead to misinterpretations of the code and potentially unsafe installations. The NEC also includes explanatory material, such as fine print notes and informational notes, to help clarify the intent of the requirements. These notes are not part of the code itself, but they can provide valuable guidance on how to apply the requirements in specific situations. The NEC is a complex document, and it is important to have a thorough understanding of the code before attempting to install electrical wiring or equipment. If you are not sure how to apply a particular requirement, it is best to consult with a qualified electrical inspector or engineer. The NEC is constantly evolving to keep pace with new technologies and changing safety practices. It is important to stay up to date in the latest edition of the NEC to ensure that your installations are safe and compliant. The National Fire Protection Association offers a variety of training courses and resources to help electrical professionals understand and apply the NEC. These resources can be invaluable for staying up to date on the latest changes to the code and for ensuring that your installations meet the highest standards of safety. The NEC is an essential tool for anyone who works with electricity. By understanding the requirements of the NEC, electrical professionals can ensure that their installations are safe, compliant, and reliable.